Welcome back. In this video we're gonna try to evaluate this integral. Here our function is 1 over the square root of x minus 2 and the bounds are 2 and 4. This is an improper integral of the second kind. So we don't have plus infinity or minus infinity, but we have a number that we have a problem in. Note here when we plug 2, we have a problem. Okay, so basically when we plug 2 from the right, so when we take the limit as x goes to 2 from the right, we're gonna have a problem. Here we're gonna have 1 over small values, which is plus infinity. Okay, so this is an improper integral of the second kind. To deal with this kind of problems, if we know the primitive, we can solve. But if we don't, we have to prove that this integral exists or doesn't exist using some other techniques. But here we can find a primitive. Okay, but before doing so, we can write the problem here in 2. Note at 4 we have no problem. When we plug 4 here, we're gonna have the square root of 2, 1 over the square root of 2. Therefore we can rewrite this question as, so here we have a problem in 2, therefore we're gonna take the limit as x goes to 2 from the right. Okay, and we're gonna find compute this integral first. Here we change the variable of integration to make it nicer, and this is the right way to do it. Okay, we don't want to keep x here. Okay, now we can see that we can integrate, and we see what happens to the limit as x goes to 2 from the right. Another thing that we can do here is that we can graph our function. Okay, we can give a rough sketch. Here we have 1, let's have this one as 2. So this is the x-axis, this is the y-axis. We can, so here when I go to 2 from the right, I'm gonna reach infinity. So here 1, this is 4. So when I'm at 4, I have 1 over the square root of 2. Okay, so my function will be decreasing. Okay, and computing this integral is basically finding this area here. Okay, is it finite or infinite? This is the problem. So this is the aim of our question here. So once we find this, we're gonna say, is this area here, this shaded area in black between x is 2 and the bounds 2 and 4 and the graph of the function 1 over, so this is my function 1 over the square root of x minus 2. Okay, so I will be able to say if this is finite or infinite. Okay, the good thing is that we know a primitive. If we don't know the primitive, we have to say from the bounds whether this integral is convergent or divergent. That's why I say before we compute the integral, we have to prove or to show if the integral exists, finite or doesn't exist, or it's infinite. Okay, so here we know a primitive of this one, we know how to do it. Okay, using the power rule, we can easily find primitive. Okay, so here we have the limit as x goes to 2 from the right. Here 1/2 the square root of t minus 2, and I have to evaluate between x and 4. Okay, now I can can compute this value here. After that, I will take the limit. Okay, so this will give me x goes to 2 from the right, 1/2, and when I plug t as 4, I have the square root of 2 minus the square root of x minus 2. Okay, so now I can take my limit as x goes to 2 from the right. Here I get 0, and therefore I have a finite value, which is the square root of 2 over 2. That means my integral is convergent, and it's geometrically speaking, this is the area here, since my function is positive. Okay, that this area is the square root of 2 over 2. So this whole area here. Sometimes when you graph it, it seems infinite, but it's finite. And note here that in my interval, my function, which is this one, is strictly bigger than 0. Okay, so this is one way of showing this one is convergent. We know the primitive. That's the good thing. If we don't, we have to deal with these bounds, and we're gonna see what we can do. Okay, so this is a quick overview of the improper integral. Sometimes if you have a problem, you can change this one to 0, okay, by using this change variable. Y is x minus 2. Note that when x is 2, we will get to 0, and this one will be 2. Okay, and my function will be 1 over the square root of y dy. Okay, and therefore we see that we still have the same issue, but it moved to 0 instead of 2. Okay, but we don't want to use this change variable because it's clear that this one is easier. If we have some hard or difficult integrals, sometimes we have to change the variable to make it easier. Okay, so we'll come back and talk about more problems and how to deal with improper integrals the right way. Thank you very much.